Good afternoon. My name is Amar Akhtar, Director of Product Management in the IoT group. So I'm in charge of the industry products that we're making. And
hi, Randy Birdsall, Director of Technical Marketing for IoT software.
Great. So thank you for coming in. So at any point, just like stop and ask questions. I've been told you're not shy at all. So please don't start now. Next slide. This is not working. So just sort of like, we're going to start really at the top level of IoT. We can go down in as much detail as you like. But just from our experience in IoT in and of itself, you've seen these huge numbers, trillions of dollars, IoT, this, that, and the other. But really what it comes down to for Cisco's customers is IoT allows them to improve operations, be more efficient in whatever is going on. It could be truck routing, those types of things. Drive new forms of revenue. We see that with machine builders, for example, that they have this super expensive robot and they would like to provide field diagnostic capabilities, or they would like to charge for predictive maintenance through that particular robot and things of that nature. And then enhance customer experience. And I think the easiest place for that to see is, for example, in the retail area. We're able to do measurements of queue lengths. How do you optimize on wait times and things of that nature? Next slide. Now, the problems that we see, and these are generally on the technology side, there's all sorts of like change management things that are going on with folks that have never dealt with digitization and things of that nature. And you see that in all sorts of industries, for example, in oil and gas, on refineries, on the manufacturing floor, things of that nature. But these are more on the technology side. So there is the complexity of actually connecting and securing devices themselves. A lot of these devices, if they are smart devices, they have weird protocols. We are the protocol company, but these are super weird protocols, sometimes not made by networking folks, and they may misbehave and things of that nature. So that's problem number one. Problem number two is, depending on the type of environment and the use case, it may be super distributed, and there may be things that are moving around. School buses that we're tagging into the OBD port, and we're grabbing data out, and we're shooting it into the cloud. Highly distributed, highly mobile. We have projects that involve oil wells. So in the Gulf of Thailand, there's several thousand oil wells, highly distributed, highly remote, not a lot of bandwidth. But then we also have cases, you may have a factory that's super, it's not that distributed, but it's super complex within the factory in itself, lots of variability. And one of the things that we've noticed with IoT itself is, especially if you're early in the stage of IoT, as you start looking at that data and understanding what that data means, that transition from taking this analog world and putting it into numbers, there's lots of opportunities that people start thinking about. So the use cases themselves evolve very rapidly as you start to visualize the data, as you start to see here's the actions that are possible once you have that data under your control. And then, so what that means is it's a rapidly changing landscape in terms of outcomes and things of that nature. And then finally is just from a manageability perspective. Like think about as you're managing your network devices, multiply that by 10 or 100. How do you manage and monitor all these different types of sensors that are out there? And these are sitting out sometimes in the wild. We're doing stuff in cities environments where we're looking at temperature and things, and the sensor will just sort of like decide, I'm just not going to work today. Everything will be 0, or it'll just decide it's just 75 degrees all the time. Like how do you detect those types of things, and how do you manage the communications and just the operational aspects of things? Good so far? All right, keep moving forward. Next slide.
Yes, sir.
The magic keywords. Like Siri, man.
I'll give you my finger, and you just squeeze it every time you want a new slide.
That's actually, it was going like this. All right. So this is broken down into two different parts. Just sort of thinking about like how it maps into the products themselves. So there's the IoT software itself, and then there's the networking and services of that nature itself. And some of these are coming in from the specialized hardened routers and switches that we have. I think we've got some examples in here of that. But the other ones are things that you're already familiar with, StealthWatch, ICE, those types of things that continue to be important in these types of environments as well. All right, so the first part is connectivity. The idea is you've got this funny looking robot. How do you get that onboarded in a quick, easy way? You may not even have access to the internet in those types of, like wired Ethernet in those types of places. How do you make that easy? So Kinetic actually provides a multitude of different types of, we call them connectors, that allow you to connect to these things. It could be Modbus, it could be a serial port, it could be an IP interface, but it's all sorts of different types of things going on over there. And then on the networking side, how do you securely bring that device into the network in of itself? How do you profile that device from a security standpoint? How do you monitor that device? How do you protect that type of device? You should be all thinking about all the segmentation and all those types of things. They continue to exist, and they're actually even more important in these environments because these are people's businesses that are actually working. What was it, $300 million?
1 quarter, 300 million for Merck for non-PETA.
Yeah, from a ransomware thing.
Yeah, not
yep.
PETA.
Right, next, connection management. So you're now talking to that particular guy. How do you manage that particular connection, liveliness, this, that, and the other? How many of you guys are familiar with Jasper? How many of you guys know what an MVNO is? Do you really? No, I'm just kidding. So MVNO, the way I think about it, when you go to Best Buy, you go past the Sprint and the AT&T rack, you do know what it is. And there's like Bob's cell phone company. That guy is an MVNO. And Bob does not actually have a cell phone company. He's buying minutes from AT&T or somebody, and he's reselling them. So MVNO stands for Mobile Virtual Network Operator. And what Jasper does is, it's basically, the best way of thinking about it, it's ICE for MVNO. It allows companies like Tesla to be able to distribute their own SIMs under their name. They may use a global network provider, AT&T, and it allows them to be able to regulate how people connect to their network and to apply policies. That's what connection management from the perspective of Jasper actually is. It's ICE for MVNO. That's the best way I found to actually explain it quickly. Moving forward, next slide. Then there's the data extraction. Now you're getting this data, it's like random stuff. One guy's telling it to you in Celsius, the other guy's telling it to you in Fahrenheit, the next one's in Kelvin, and the other one might be just sort of making up a number and says, you take that number, you divide by 40, and you add 2. There are people like that. Like, this is my magical way of representing temperature. That needs to turn into what we call data extraction. So we take that data and we normalize it. So it doesn't matter which sensor you're actually talking to. As you present to the higher layers that are actually making use of that data, that is normalized against all these different types of sources. If you think about what's been going on in the network management world, think about data you could have been getting from SNMP, but also from CLI and these types of things. There is a normalization abstraction factor that's actually happening over there. The entire SDN world was all about those types of things, as you know, those model-specific languages and things like that. Okay. Similar type of stuff going on the networking side in terms of onboarding and making sure that they're actually living within their profiles. Next slide. There's the edge processing. Now you take that data and then you do things with it. You may have rules that if the temperature in the last 5 minutes exceeds this value, or what is the baseline vibration value, what are the boundaries of vibration. These are where the business rules and the edge processing itself happens, and you want to have this happen as closest to the event itself. We have customers where you're drilling an oil well, and you like to see the feedback from the drill bit that's actually going through, so you actually can react to the event faster on the event itself. The alternative for that is actually to shoot that data back into the data cloud, and somebody is actually doing remote monitoring. That in itself could take days, because in some of these cases you actually have a USB disk that traverses ships to get to the actual cloud and of it that way. So there's edge processing. Keep moving forward. And on the edge processing side, we have the capability to run compute jobs into the routers and switches themselves. Of course, there's the UCSs if you need more performance. There's also the deployment of those microservices across those particular items, and we can talk about that as well. There's digital data visualization, and what that's about is taking that data once it's cooked, once it's processed, and presenting it in a usable way. And this could be doing effectively in Excel. You have these things called pivot tables of aggregating the data, reorganizing that data in a useful way. Think about NetFlow. What does NetFlow do? It takes off all this tabulations and it tries to summarize this was happening, this is how many packets are seen. There's actually even a machine learning aspect that's going on in StealthWatch and these types of things. So very similar to the aspect of how do you represent this data to actually allow decision making to happen. Keep going forward. And then once you have that data in of itself, you've done your own sort of basic visualization. What do you do with this data from that point forward? Do you share it with other folks? A lot of the companies that we deal with, they have subcontractors that are doing parts of other jobs. If you look at an auto manufacturer, they have all sorts of different companies that are working on the same line or providing parts to that same line, but they need access to bits and pieces of that data in itself. How do you do that distribution? So we actually have components that allow you to share subsets of the data with trusted parties. You can subselect data and share it in a real-time fashion, and they can then do their own processing against it as well. Next slide. And then finally, we allow you to move data into the cloud. We have integrations against IBM Bluemix, AWS, Azure. I think we'll do a demo with Bluemix with Watson in a bit.
Yep.
Keep moving forward. Next slide. Okay, so that was one view of the stack. So if you were to look at it in a logical way, there's the things down at the bottom. Some of these might be smart. They may have augmentation in terms of sensors that are attached to it. Either way, we go and we connect to these particular types of sensors or to the devices themselves. We then take that data and then we can process it. We can the baselining jobs can actually be farmed out either to the devices themselves, right next to the collection. There was actually a really nice story about one of these oil wells. As they were sticking a fiber optic cable down the well, they bent the cable. And all the temperature readings that were coming out of that guy were 5 degrees off. So at the edge, so it was really expensive to go run a new cable. So what they did was they put in like a little microservice that went in and actually did that correction right at the source. So everything upstream was always at the right temperature, at the right reading. Okay. Number 4, of course, we do the real-time monitoring. That's where the visualizations and any actions against that data that need to be done. And that may be going downstream, back into actions against the devices themselves, or it could be going off and executing jobs in the cloud or turning on lights and things of that nature as well, the little flashy lights. We talked about secure data controls, and then the control shared in the cloud. And let's go to the next slide. No questions so far?
I have a question.
Go ahead, thank you.
So I've got devices,
Yeah.
distributed across a very wide geographic area. There's value in data that these devices generate. I want to get it back to a central location and then extract value from this data, right? And Kinetic is what extracts that value.
Yes.
Now,
It provides the connectivity, it does the edge processing, these types of things, yeah.
So I would assume that a lot of what I need to do with that data is going to be very industry specific. How does Connect interact with, does it directly provide value or does it interact with industry specific applications? What does that look like?
I like the way you just worded it because that's actually my job. So there's 2 parts to Kinetic. One is what we call the horizontal platform, and think of that as the building blocks. Like if you were already a domain expert, you're already familiar with programming and this, that, and the other, you can actually go off and buy the horizontal platform and you can build your own application on top of it. We expect, for the most part, this will be system integrators or developers themselves that are trying to make applications. Perhaps it might be the innovation team inside of an end user company that's trying to sort of prove out a couple of different things. We also make what are called, I like your term, industry products. Right? And a couple of the industry products that we have ones for equipment health monitoring, right? So we specifically have sensors. We bundle sensors together. They collect temperature, they collect vibration. We bring that data back. We're able to do baselining against it. A really good one, if we'll have time today to show, is machine productivity. And in this one, we actually connect to CNC machines, and these are multi-million-dollar machines that are actually cutting out parts and things of that nature. And you can program them with multiple jobs. It could be like a high rate, high mix. So they're running different programs every other minute. And what we can then do is say, well, how many widgets were produced? How long did it take to make widget A on average? And we can present a histogram of, machine 100 took 5 minutes. Machine 1 took 2 minutes to make the exact same part. So then you can do some analysis against it. Well, why is that machine not working as well? Maybe the drill needs to be replaced. All those. So these are very specific use cases that that are basically products themselves for those particular items. So there's things going on in roadways with transportation. If you're familiar with DSRC, it's a protocol that the cars themselves emit every 10 seconds about the car. GPS location, braking, speed, all that different type of stuff. So we collect that data and we do traffic measurements and things of that nature as well. And these are, I would say, quote unquote, off-the-shelf products that have their own feature velocity, they have their own roadmaps and things of that nature as well.
And these are Cisco developed products?
Yes.
What are the major verticals where you have those products?
Manufacturing, utilities, transportation.
Oil and gas?
Oil and gas is the other one. I gave all these examples about oil and gas.
Gotcha. And it looks like that diagram is like directly out of the CPWE.
It is.
Are
It
a lot
is.
of what you do?
Well, not directly. The things that we changed. But go ahead with your question first. Sorry.
So are Rockwell Integrations key to a lot of these products, or is that more just in specific manufacturing environments?
So Rockwell is one of our partners for this. So they actually use our switches, and they actually, IND, which is a software product that Randy will show in a bit. Rockwell has their own version as a rebranded version of the same thing, Factory Talk network configurator and things like that. So Rockwell's our partner, and they basically act as our OEM/distributor element in that way. And in fact, CPW was developed with Rockwell. There's a Purdue model of how the industry actually likes to see these things laid out. There's a general agreement that there's something called a cell. You keep it separate from other cells, those types of things.
Yeah.
Does that help a little bit?
Yeah.
Right, so the parts that are different from CPWE, so is down here at the cell level, what you'll see is I've added in these Panduit wireless sensors. So this is coming from equipment health monitoring. That's one of the use cases that we sell, one of the products that we sell. There's another one here for eye sockets. This is bringing in energy monitoring. We're able to measure multi-phase motors, that type of thing, and how they're actually consuming energy in of it themselves. And then you see over here, the MT Connect protocol is connecting to the CNC, and it has a job running on the IE4K that's collecting that data, and then it's sending it over to the control room, which is where the IND and all your traditional network type services are actually living. Right? So yes, CPWE is our reference architecture of how we believe the factory networking layout with all the services is organized. But then as we're developing these use cases, we're mapping them onto extensions of CPWE. And the big takeaway for me in here is that with Kinetic, the idea is to actually run all these use cases on the same platform. It's not like when you buy equipment health, you just buy that one thing, and the next day when you want to buy something else, it's not like you buy an entire other stack. It's an add-on on top of that capability. And I know this is an overused word, but the idea here is actually to get the synergies from the data from EHM, marry it with the data that's coming from energy monitoring, marry it with the data that's coming from machine productivity, and now you have, as an example, I made 500 widgets per hour at the cost of 200 kilowatts. You're able to get those types of reports as well.